Okay, hello everyone. Thank you for joining me. This is our 63 meetup, uh, June 18, and we have a special guest today. We'll get to it in a second. Rich Yonts is the one we're hosting today. We'll get to his bio in a second, and we just admit more people to the meeting. Um, if you are a new member, we meet here every month, usually Tuesday, 5 p.m. Pacific time. Um, and we just discuss anything you can imagine about C++, or almost everything you can imagine. There's so many things in C++. Just to share knowledge and just increase our uh, knowledge in C++. That's the goal. If you want to speak, anything that you can think of, can be small, can be taking the whole hour. Just it's really up to you. Just approach me and we'll get it done. Um, just a quick uh, few things related to our meetup. We have a Dropbox link where I upload the slides. We have a Discord. Ask me for a link if you don't have one. The one on in the meetup page is usually expired after a few months or so. We have a YouTube channel, SDCPP Meetup YouTube channel that you can watch the previous meeting. I'm doing my best to upload the meeting the same day or the day after at the most. SDCPP Meetup Twitter handle. My handle is Kobe_CA. Usually discussing things related to programming and mostly C++. So as I mentioned today, we have a very special guest, Rich Yonts, which is writing a book in Manning publication, 100 C++ mistakes and how to avoid them. And he was generous enough to provide me a soft copy, which I am looking at, and I really like the book and how it's organized. And we have the opportunity to have a talk from the author himself and get some of the 100, just some of them today. So let's introduce our guest today, Rich Yonts. So Rich Yonts, he is a senior software engineer at Teradata and a long-time software engineer using C++, Java, and Python. Rich held a number of technical and leadership roles during his many years at IBM and Sony. As an assistant professor, he has dealt with questions and issues of undergraduate and graduate students learning programming. He has deep experience on large code bases and considers himself both student and a teacher of C++. By the way, we all like that. We all like students of C++ forever. So welcome, Rich. I'll stop sharing and you can take over. Hopefully there is no permission issues or anything like that, but just let me know.
All right. Can you see my screen here?
Yeah.
Yeah. Looks
Mhm.
okay. I'm going to minimize that so I have nothing distracting me. So if anything happens, holler. Okay. Thank you, Kobe, for the introduction. When I hear it, I kind of back off and say, really? I'm that good? I don't know. um, Now, let me explain a little bit about my history and why I got to write this book. Uh, as was stated, I've worked a long time with C++ language. In fact, I started IBM back in '78, and C++ was just an idea Mr. Strustrip's mind at that time. I dealt with C++ the first time in about 85-ish, somewhere in there, when it was Seafront. And I didn't have any reason to use it for business because we were using internal languages, but I kept poking at C++ and learning it and growing. Moved to Sony, did some work with that, spent 9 years there. And then I most recently came to Teradata. And until a year and a half ago, I was on a rather large project that was C++. Now, in the meantime, I have become an assistant professor, adjunct, so I do it part-time, and I frequently teach undergraduate students programming. So I've had a lot of experience with students stumbling through various issues and dealing with textbooks. And over the course of these years, I began to see that there's certain persistent mistakes or issues that show up. Textbooks, for the largest part, do not deal well with modern concepts. And while it would be wonderful to fantasize about writing a textbook that was heavily modern oriented, the reality is, as I've discovered, a lot of code bases exist that cannot use modern concepts. The project at Teradata that I was on was stuck at C++ 03 as a maximum level. So the idea of the book began to form in my mind because I wanted to deal with the legacy code bases and the problems often discovered in them. And then with the mindset of programmers that have dealt with that, coming to more modern platforms like myself, and I want to show you just a real quick example here. See, I'm part of the problem because I'm so steeped in the old ways of doing it, the classic C++, that I miss modern C++ myself. And many projects don't have the privilege of using the modern standards. For example, let's do this. Double D assign 3.14 int and assign D. Now, I do this kind of code all the time, line 5. I use the assignment operator, right, to initialize variables. Of course, students learn that. Every textbook that I've come across, that's the standard way of doing it. And probably many of you do similar things. You'll create the variable and use the assignment operator to initialize. But if we read this code, what does it really mean? Line 5 is very unclear. So readability is one of my key characteristics that I focus on in the book. Correctness, readability, programmer effectiveness, and then performance in that order. I still am not really strong at using more modern techniques everywhere, because this will compile just fine and run and no problems. But line 5's a mess until we do something like this. Use uniform initialization. Well, now that surprised me. That was supposed to bark at me.
Can you remove one of the you're writing dash std? Can you just write one std, just one dash instead of
there? It is. Yeah, Kobe, I sure will. I discovered that I could use either one. I forgot to save the file. See. Okay, but yes, yeah, either one works. There's what I was hoping to see, because the more modern approaches, particularly with uniform initialization, they'll tell you, hey, wait a minute, you're trying to narrow here. And this is just a trivial example, but it demonstrates the kind of mindset that has been trained over many, many years to use certain techniques, certain patterns of coding. And yet those patterns can be quite problematic. So that's part of the motivation for what spurred me to look into writing this book. Manning was gracious enough to allow me the opportunity to do so. I've been a reviewer of their books for many years, and they finally asked me if I would do something with C++, and this is what came out of it. But what I want to focus on is those programmers coming out of college, the ones that I train, that are going to come into companies that have old code, and what they're going to experience there, because they're not going to have the training to really use modern C++, and often they won't have the compilers. The project I mentioned previously, one of the main goals was stability, and we had thousands and thousands of installations, machines running code. And when you have that, you have to worry about customer stability. So once they've vetted a compiler, that's it for probably the life of the project. And all these modern C++ conveniences that make your life easier aren't necessarily there for everybody. And I have a sympathy for those people, particularly the younger, less trained ones that are going to be thrown into the fire of using the code that people like me have written, yet they're unprepared for some of the difficulties that they face. That's kind of my motivation for the book and the intended audience. I appreciate Kobe's kind words about reading it. I've had other feedback that, yeah, it's pretty interesting, good read. But the most critical feedback I've had on it was that there's no modern C++ in it. Well, that's the last third of the book. The reviewers only have gotten to see the first 2/3. And so the publisher recently asked me to restructure the book to put the modern stuff first and then drift off into the old stuff. So if my code is too old for you today, bear with me, please. Okay, let me start with a mistake that I'll just pick. I have quite a few written down, but I don't want to spend too much time. I'm going to show you the mistake. Well, okay, I got to be a professor here. The class invariant. I talk about enforcing proper class design. I get off into some theory about it, things that a class does. And then this chapter 2 talks about mistakes like failing to maintain the class invariant. And let me get to number 6. It was quite interesting writing 100 different mistakes. Okay. Overusing default constructors. This is something I see with students all the time. And if we have code using arrays, and the arrays hold elements of a class, you're probably aware that you have to have a default constructor, because when the array is created, it automatically initializes each element, and it calls the default constructor. My argument is that the textbooks should be a little more clear about this, and we should avoid two things. One, default constructors as much as possible, and two, we should avoid arrays as often as possible. Here's an example of this code. Let me see if I can fire it up. This was an example. Let's do chapter 2.
Hey, Rich, is there a way to increase the fonts a bit so people can some would have some difficulties?
Yeah. How's that?
It's good on my end, hopefully with others as well.
Okay. Mistakes 6, right? All right. Let me see if I can show the code. I want to show the code in the editor rather than the document. It's easier to read, I think. There we go. Oops, there we go. All right, this is a common, let me see if I can increase this font size on that too. There we go. Hopefully that's readable. Yeah, this is a fairly common textbook mistake, is when they're first talking about classes, they'll do something like this. And if you look at this, again, with the eyes of a new developer, or one in training, nothing looks particularly wrong. But I'm sure all of you look at this and say, wait a minute, there's no constructor here, which means line 5 will get initialized because string happens to have a default constructor, which creates the empty string. So we're going to have a valid string in there, although it's kind of meaningless to this problem because no person is going to have an empty name. So, it's kind of questionable, its value. And of course, age is going to be undefined. So I explain it, and then I come up with this. I said, if you have to have a default constructor, do something like this. And I'm surprised how few modern textbooks and C++ programming don't use the initialization list form. And I explained to my students that initializing code in the constructor body is less preferred. And this is one of those performance issues. I wasn't aware of exactly what went on, but it turns out that the initialization list form gets called regardless, whether the programmer provides it or not. So if we were to initialize all of our variables inside the constructor body, they would be default initialized, and then the constructor body runs and initializes them a second time, which is obviously a performance hit. So I try to pound it in my students' heads, please do this for performance. And it's not going to make a huge difference, but it's a good habit to get into. And the better the habits you have, the better you're going to code in the future. And another example of that is right here. Every textbook I've ever seen would have this for loop, do I++. It just seems to be the common pattern. But I stress, do the prefix version of increment as opposed to postfix. Again, it's not going to really save much unless, of course, you're dealing with data containers with 1 billion elements in it, and then it's going to have a noticeable performance hit. If by chance any one of you are not familiar with the difference of prefix increment and postfix increment. Prefix increment updates the value and returns it. The postfix value the postfix version saves the value, increments it, and then returns the saved copy. So there's a data movement operation. Even if it's in cache, it's more expensive. So because there's a secondary variable. So that's one of the mistakes. It's prefix versus postfix. And it's, again, a good habit just to get into. A number of performance habits you can get into early on and just use those as patterns the rest of your programming time, and they're beneficial. Okay, let's look at another one. Yeah, I'm not going to jump into this one, but this is a big one. A number of authors mention the fact that you're going to save typing or code reuse as a reason for inheritance. I try to disabuse the students of that, saying that's never a reason for inheritance. The reason for inheritance is because we have related classes that we want to treat generically, in aggregate, a collection of them. Code reuse is a benefit, never a reason. All right. That's that chapter. I'm not going to spend too much time on the early chapters. I just wanted to show a couple. Chapter 3 has a few that I want to bring out. Let you just look at them. And again, these are problems that I see in students' code, and these are problems I see in older code bases. It's all through there. All right, let's do number 9. Oops, I went past it. There we go. Okay, providing trivial mutators. Again, a textbook mistake. The authors very frequently say, for every instance variable you have, write an accessor and a mutator. Oh, 9. Da, 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 da. I normally work on a 4K screen, so this is like just enormous to me. Here we go. Circle. What are we doing here? Circle, circle, circle. Trivial non-validating mutator. Right. Line 10. Typical code. I see it in code bases frequently. I see it in textbooks. And doesn't look like line 10 has a problem. But it has a nasty problem. And that is demonstrated by this line of code, 16. My emphasis in the first few chapters is on the class invariant. And what does this mean? What does line 16 mean to a circle? It has a negative radius. That's a violation of the invariant. Because a circle, it can have a 0 radius, but it can never have a negative one. But this code, these trivial mutators, line 10, allows us to throw anything at it. And there's no validation here. So I think it's this one. I wrote this long enough ago that I don't remember the difference between circle good and circle better, but well, we'll just look at circle good. This is a validating radius. Oh, I think it is that the mutator calls that. That's right. We can create a circle now with a valid radius, and when we call it with something that would violate the class invariant, we throw an exception. That is the ideal way to handle class invariant violations. You really have to try never to initialize an instance of a class and allow it to have any bad data. That is a common problem that students will do. They'll put a mutator in that it lets invalid values in, but the accessor, they'll do the validation there. And I tell them, great idea, but wrongly done. You never let the instance be bad. And if you do get to the point where your input data is invalid, you've got to throw an exception and handle that. You can't let that instance get have a violation of the class invariant. So these things seem simple, but they're pervasive. And old code bases allow, too frequently allow this. And when these new programmers come in, they're going to be victims of that mentality. So again, that's the motivation of the book, is to try to help them see some of the mistakes we old programmers did. Okay, number 10. There we go. Seems like protected instance variables is just so cool. And this mistake, I have a very strong argument against ever using those. I tell my students, private data only. Bad. Okay. The reason, in simple terms, is that we have the person class, and they have a protected age. And notice the trouble that the developer went through to validate the age in the constructor. If age is negative, we throw an exception. We don't want it, we don't want those negative ages. Oh, that's great. That's good work. But look at line 23. Somebody else, we're going to assume, wrote class student. And they knew that there's an age variable protected there so they could access it. So they went ahead and wrote their own set age mutator and decided that whatever the value is that's passed in, they're just going to put it right in there and move on. And so the class invariant of class person, which was carefully protected, gets violated by allowing protected variables in the derived class. And that's very easy to do, particularly in larger inheritance hierarchies. If somebody is unaware of the class invariance of their base classes, they're in different files, or they're in a library or something and whatnot, and they can't really see it. So they look at the protected variables and just manipulate them themselves. So I argue very strongly this is a bad design. And what we should do is always let the class with the instance variables, make them private, and always let it manage the validity. And then in our derived classes, well, quit scrolling, please. We just call the existing functionality of the base class always, always, always. So yeah. Now I let me see. Yeah, here we go. Jane's set age, and of course it's calling the base class version of set age, and it's going to throw the exception because that would violate the class invariant. Back here in the bad code, this works. I mean, well, it works in the sense that it doesn't throw the exception. It violates the class invariant because we had this unfortunate duplication of mutating without maintaining the class invariant. All right. So I'm not a fan at all of protected variables, and this mistake explains why very clearly. Mistaken operator assign versus copy constructor. Now this is one of those that I don't know that most textbooks, perhaps any, really even talk about. And I'm sure you are aware that if you don't write operator assign or copy constructor, the compiler will help you out by writing its own versions of them. So what could go wrong, right? That's 11. Let me. Yeah, what could possibly go wrong? Let's get this and make it bigger. Now, this is a hokey example. I wouldn't do it this way, but I had to make an example. When we have dynamic memory, all of a sudden, those defaulted copy constructor assignment operator implementations the compiler gives you for free rarely, if ever, work correctly. So this mistake goes through and it talks about this, and shows, let's see. Yeah, it shows that if we're going to have a copy constructor, we should undoubtedly duplicate the dynamic resources. Certainly there will be use cases where sharing would be right, but the key is that the developer has to understand I'm sharing and I intend to share. What this mistake did here is it did not anticipate that these file names would be shared. They expected each input reader to have its own group of them, but since they were shared, it broke. So the solution, of course, in both the copy constructor and the assignment operator is to copy those values, which of course the compiler provided versions do not do. They do a shallow copy, so it just means the pointers get copied, not the values. So this mistake is almost entirely untalked about in textbooks. They rarely even discuss copy semantics. And I think we know that that's a pretty big deal in C++. Okay, let me jump out of the older stuff and let me get to one of my favorite sections, and that is chapter 10. Chapter 10 is about it's about C idioms that seem to show up in C++, modern C++ code. Without jumping into it, mistake 76, failing to use move semantics. That's a big one for performance. If I'm sure all of you have written your own version and you're aware that move semantics has some interesting characteristics. The source object, depending upon how it's implemented, can become basically empty or null or whatever, because we're trying to move the information over, and that source now is an invalid object, probably going out of scope. Textbooks don't talk about that, which means if the student or new programmer were to deal with it, they could really get caught unawares. Yeah, okay. This mistake talks about empty exception specifications. C++, classic C++ put in the throws keyword, and the intent was very good, but its implementation and use kind of left a lot to be desired. I don't remember all the details at the moment, but the throws clause, as I recall it, and if anybody wants to jump in and correct this, that'd be wonderful. If you said you throw an exception, or a list of exceptions, exception code would be built to handle those, but also code would be put in place to determine if an exception was thrown that wasn't in that list. And if an exception that is not in that list happens to get thrown, it would call terminate. And no destructors would be called, nothing. We just terminate the program very suddenly. So that characteristic of the throws, or the throw keyword, I'm using Java throws, but yeah, the throw could definitely cause system related problems if you happen to be accessing or creating system level resource handles. Although I didn't make that mistake at Sony, I made something similar where I exhausted system resources and our servers were crashing, although my program was running fine, and then it would restart itself. And yeah, so I blew other people out of the water. That was a painful learning experience. Yeah. Here's one that I try to teach students to use the override keyword. I tried to make a joke here, if you can see it. I have in the base class, I have a, let me bring the code up. That's, yeah. So you can see it better. Chapter 10, mistake. 78. Yeah. Our base class has line 8. We have a virtual function, and it returns area of 0, which that's questionable. Square inherits from it, and it supplies its polymorphic function there, area. At least I pronounce line 8's area and line 14's aria a little differently, but it's meant to be sort of a pun there. It's a typo, and that's the point. Yet this code will create it and run it. And here, when we're calling the polymorphic area function, the the square will, of course, it won't run line 14. It runs line 8 because that's its base class definition. But as far as we know, the code compiles and it looks like it runs. So we're lulled into a sense of thinking all is well. So I stress, and I'm sure those of you that do this understand this, use the override keyword, because then you get the compiler to help you ensure that no typos exist. And I had to fight that. I think I was at Sony where I stumbled onto that, and I had to fight that because one of the functions was misnamed, barely, but it was misnamed. And of course, the compiler happily compiled it and went on, and it took a long time to figure out that the function name was in fact different. So the override keyword working with the virtual keyword in the base class gives you some protection from that kind of flub. Now, will it happen often? No, but does it happen? Yes. Okay. Here's one that I'm going to ask you to think about. In modern C++, let me just show the modern here. I'll bring the code up, but I'll just highlight it. This is 79, yes. When we don't want a function, we can use the equal delete keyword to prevent the member from being accessible or usable, whatever. So line 10 here, there we go, line 10. We don't want a copy constructor, so we use assign delete there. And that prevents line 18 from compiling. I cannot assign C1 to C2 because the copy constructor has been deleted. But how do you solve that if you're not using the modern C++ approach? Well, the only way I know to do it, you do something like that. You put the copy constructor in the private zone and you give it no body. The problem with that, of course, is it's far less clear, unless you really understand it, it's far less clear what line 7 here is doing. It almost looks like it's an abstract method, that attempt. We're defining it, but we're not giving it a body. We expect somebody else to. That's the way my mind would drift because of my familiarity with Java. But in fact, I'm trying to delete the operator assign here. Goodness, I have a hair bugging me. So modern C++ allows you to be bold and get right out in the open here and saying, hey, the assignment operator, I think I called it copy constructor earlier. The assignment operator is not valid. We're deleting it. So it gives us a very clear, documented way of preventing its use. So no surprises when line 18 doesn't work. Back here, it might be a surprise. I don't know. It might not be clear. So readability, very important. And that's what this particular mistake deals with, is really the readability of this when we want to delete various functions. All right. Couple more. Let's jump to chapter 12. This is where some of the better modern stuff shows up. Yeah. Improvements in text formatting. I want to talk about variadic templates. Without variadic templates, well, let's see if I can show that. My recommendation was to use arrays or vectors, preferably, to pass variadic parameters to a function. Now, the old C way of doing it, the VA args and all that stuff, I devote an entire mistake to that VA args business and how to improve that and this is in the pre-modern C++ realm, how to use vectors to do variadic parameters and don't use the VA args. Okay, which one is this? 93. Da, 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 da. Yeah. Create a vector, populate the vector, and then pass the vector as the variadic args. It works. We use vals, and then in here we iterate through the values and wonder why these are left in here. It's really a complicated business to keep code in the document and code on your hard drive coordinated. I found that out. Okay, variadic here. Use the pack notation. Really simple. Works, as you can see here, for any number of parameters. Yeah, so
This one actually shows up in two places in the pre-modern C++. The recommend is don't use VARGs, use a vector. And here in modern is don't use a vector, use variadic parameters. If you haven't used them, they're really neat. They're really cool. Now, every time I get around to working with them, since I do it, like once a year or less frequently, I have to really stop and think about the syntax. All right, let's do 95. These are a couple of my favorites. I kind of threw these in just because I think they're cool. CD 095 code. A mistake is devoted to discouraging the use of scanf, printf, those kind of functions, which show up surprisingly frequently, even in more modern C++ code bases. This is okay. I mean, it's not hard to read, particularly if you've done it. I don't. Yeah, it's the other mistake I have talking about it that tries to dissuade you from using that. Here, we're trying to output a GPA, and we're trying to put it with 2 decimal points, because we don't think of a GPA as a 3.857. We just say a 3.85 or 3.8 sometimes. Here's more modern C++ of how to do it, not using the sprintf kind of formatting. And GPA of, and then we said set the width to 4 minus the length of the GPA actual size, and you set fills with zeros and print out a blank. This was a pain to research and get it right. So this is offered as a better way than the sprintf way. I actually think the sprintf's easier. It's just not modern C++. And if your compiler has it implemented, and not all do, std format offers a much more Pythonic approach to outputting these values. You put the format string in here, but rather than percents and whatnot, you just put the curly braces. And the one distinct advantage of that is the sprintf, when you put in a format specifier, you can misspecify it. I could try to be outputting a double, but tell it it's an integer, or vice versa. And bless the code soul, it will try to do it, and sometimes it just doesn't work well. Here, we're just saying braces, and the compiler figures out the proper type and how to output it properly. So here I am, dyna name, age, GPA. I don't care what data type they are. When I'm writing my output statement, I just say output those values, and it figures it all out for me to know how to format it appropriately. And yes, you can specify here that we want the GPA to be 4 characters. I forget the exact meaning of the caret symbol there, but we're going to limit it to 4. So, and we're going to fill it with zeros. So if they have a 3 or a 3.0, it'll get 3.00. in the end, just like this example. It'll append that 0 filler. So STID format is really a very nice improvement for writing things out when you have to, because I know we humans like keeping our columns lined up when they're numbers and whatnot, and this can really, really help. And I looked at the time and just realized I'm about 2 minutes to go, so I probably ought to stop it here before I run over time. That I have various others. So Kobe, I'm going to turn it back to you with this final comment of saying that if anyone wants to offer feedback, please do. I mean, if you think it's a great idea for a book, nice, glad to hear that. If you think it's a dumb idea, I'd like to hear why. And Kobe has, you want to mention this, Kobe, or you want me to, about the 3 codes?
Which one?
The codes. Those,
oh yeah, the codes. Yeah, of course.
Yeah, I gave Kobe 3 codes for free access to the online book, and somebody's going to win it, and you can look at the book.
Yeah, just contact me, Discord or Meetup, and I'll just give away the 3 of them. We have another minute. If someone has any question, a minute or 2, we can have another minute or 2 if that's fine. Rich, do you see students struggle with the modern, like until 98 and 03? Some people say that it's easier to remember the rules, and starting from 11 and above, it's harder. Do you see people struggle, like newcomers struggle with the language, especially the modern part, because there's a lot of things, new rules, and a lot of things to remember and deal with?
I think if we really threw the modern parts at them, they would struggle some more, because C++ is a very complex language. But the textbooks almost never introduce anything modern. So I try to, but like uniform initialization, I just think that's a great thing that they can learn, and they don't have to learn all the subtleties of the other ways of initializing. I don't think they have enough exposure to think that modern is complex, simply because they're ignorant of it.
Okay, thanks. Any other questions?
Yeah, hi. I was wondering, what, from your perspective, this is Dominic here, by the way, are some of the main memory safety errors? I mean, I think we all know kind of like unique pointer, shared pointer, like in modern C++ and RAII, the pattern. But you know, apart from this sort of standard advice, there's sort of a you know, what some of your experience like are the top, is a top error to make with memory safety?
From my experience, professional experience, RAII is rarely used, and maybe that's just the code bases I've been in. I think it should be used a lot more. Probably 4, 5, maybe even 6 mistakes in the book talk about RAII and the various consequences of not doing it. I do have unique pointers and shared pointers in there as separate subjects. I'm a huge fan of RAII because I've made enough mistakes of my own through the years of not doing something patterned like that. So I've hurt myself. Yeah, I think the standard advice is pretty good, really.
I see a question here. It says, can you clarify the publication status? It's in beta. It's on the Manning site. You could see it on the Manning site. It's in beta. All the writing has been done, but there's still some editing to do. Feedback comments need to get addressed. So I'm still doing that.
Okay. Thanks, Rich. So there are no other questions. We'll let you go. Thank you so much for your presentation. And
You're welcome.
yeah, and see you all next month. Take care.
Bye, y'all. Thanks.
Bye-bye.
Thank you.